So hopefully you guys are itching now and say, all right, let's see this in action. So we do have this Keras implementation, which we'll see if we have enough time. I don't want to go through it too quickly. If we have more time, we'll save it for tomorrow if we need to. But the one part I want to mention about is this playground TensorFlow. So I don't know if anyone's ever seen this before, but TensorFlow, which is basically a package for machine learning, mostly neural networks and stuff like this. It's created by Google. If you're curious, there's a kind of equivalent one, PyTorch. It actually uses Keras, which is used inside our curriculum and is a very popular package. You can actually build these neural networks. And what's really great, I strongly suggest playing around with this, is that we can change all these hyperparameters. You can see the learning rate, activation, regularization. These are things to basically avoid us from overfitting. And then we have our neural networks here. So if you imagine these, even though they're kind of colored through here, you can imagine each of these essentially are those little nodes, right? So in this case, we have two different inputs going through here, our different features, right? We have our hidden layer right here. Which turns out we actually have two hidden layers. And at the very end, it's going to say, is this diagram, which is the actual true part, is this going to be orange or blue, right? Based on this, what's it called? This feature here versus this feature here. Okay. So what's kind of cool is that we can, you can do all these different parts, but what I really wanted to show is that these features are saying, okay, like, is it, on the left side of the, let's say, it's going to say if it's on the left side, it's going to be orange, right? And if it's on the bottom, it's going to be orange. And essentially these are different features in here. And then we're going to feed this through, and these little lines here are going to represent our weights. So what's really cool is that you can actually see this if I do it one by one. It's going to feed the data through it once, right? See how well it does, and then feed it, do backpropagation backwards, adjust the weights, and then try that over and over again until we get closer and closer. So it's kind of cool. You can actually step little by little here. And you can see on this side right here, it's actually saying how well the loss is. So the lower the loss is, the better. So if I just go ahead and like run this through right here, I can go step by step. So each time I click this arrow, it's pushing it through and then propagating the arrow backwards and adjusting the weights. So you can see here, for example, these weights are negative like 0.57, 0.58. As we kind of go forward a little bit more, you can see it getting better and better on this side. And you can see here, the weights are being adjusted as well. And note that the weights are also changed. What I really like about this though, is that you can really see how these two things combine together to make this new linear separator. So you can see here is that before we just had straight lines, left and right, a linear separator basically right down the middle, separator right here, and then combined together, we actually get a little more complicated right here. And in fact, we can then combine these even further to create these even more complicated structures. And then these structures together will actually make the prediction overall. Okay, so if I restart this, I think it's kind of fun to see in like real time. I'm gonna make a really small learning rate so we can kind of see it go through. So if you see this part, they're kind of like the weights are being adjusted as we go through. That might be too small. Let's try it a little bit faster. So you can see here a little bit being adjusted. And what's happening here is that it's trying to figure out what's the best way to adjust these weights to make a better and better prediction. So you can see here it's improving over time. And essentially all it's doing is going through, feeding the data through, making changes, and feeding it backwards. It's a great visual example. What's really cool too is that you can actually add, in this case, on TensorFlow, on this like playground, you can actually add extra features too. So you can get more complicated features, which it turns out in neural networks and machine learning in general, sometimes creating the right feature is a more efficient way of getting the neural network or machine learning algorithm to do what you want. Essentially, it's you're feeding it the right information, which hopefully that makes sense, right? If you don't have the right information, there's no way you can make any predictions. So a lot of times feature engineering can be more important. So this is a relatively simple one. I mean, simple in the sense that like, it's just two concentric, areas. But we can get into more complicated, for example, like if I have like this spiral right here. So this spiral obviously is going to be really difficult. In fact, I'm going to go ahead and speed it up to 0.03 again. And I go ahead and run this through, and you're going to see this neural network. It's going to really struggle trying to like find, you can see that trying to figure out the blue. It's having a hard time figuring this out. So in this case, you might actually add in like more features. For example, if I add in like this feature and restart this going through, and maybe I'm just kind of playing around, just kind of messing with an extra hidden layer. And I run this through here, it can do a little bit better. But you notice that basically in order to get a more complicated, what's it called? More complicated setup like this data set, I'm gonna have to add more complexity into here. And you can see it's trying really hard, like it's close, but you can see it's not quite going through here. And you can see it kind of petering out, essentially, like it's reaching this point where it's underfitting now. So if I add more complexity and stuff like this, I'm going to add just a lot going through. You can start seeing it as we add more complexity. It's doing a lot better than it did before. So if I just pause it right there, you can already see it's already starting to form that curve going through. And this is really how you should think of your neural networks, is that adding more complexity in here, and you can see these complicated little patterns in here and kind of putting this together, is that as you add more and more complexity to it, it's enabled to find these more difficult problems and stuff like this. But also it's going to take more time in general because there's more parameters to do. And so, oh, it looks like it found that nice little local minimum where, you know, if you notice, it's probably pretty good for this data set. But if we added more points in here, you probably would see it wouldn't do perfectly, right? But you can see it's got a nice thing here, and you can see it basically flattened out, even though this epoch is still trying to find if there's any adjustments, and it's maybe adjusting a little bit, but probably not very much. Okay, cool. So anyway, I strongly suggest kind of playing around with this, and then next time we'll actually go ahead and check out this Keras implementation. So we'll actually try this out on a data set and see, you know, how do you actually code this, right? Now that we kind of the conceptual part, and we'll talk about also how to modify our neural network to ensure that we don't overfit and stuff like that in the different optimizations. Okay, cool. Right. So I could stop recording here, and I'm kind of like right at time, right? So I'll stop here.